Hello everyone, welcome to my YouTube channel Trance. Today we are going to solve a question based on random variables. This question, although it seems easy, but many a times people commit silly mistakes. Without wasting any further time, let us go to the question. Yes. So given that x is uniformly distributed between 0 and 1 and y is exponentially distributed with the parameter lambda such that lambda is positive and that x and y are independent random variables. Find probability that x is less than equal to y. So given that x is distributed uniformly between 0 and 1. So we'll first sketch the graph. So x, fx of x. Uniform means a constant value. And the range is 0 to 1. Now we know that this area should be equal to 1. So therefore this height must be equal to 1. Okay. Now y is distributed as lambda into e to the power minus lambda y. For y positive and 0 otherwise. This is what exponential distribution means. And let's draw the graph. This is y. This will be fy of y. And it will decay. When you put y equals to 0, it will have a value of lambda and it will tend to 0. Okay. So in order to solve this question, first of all, we'll find f of xy. Because these are independent, can be broken down to this, which leads us to f of x. Fx of x will become 1, and this will become lambda into e to the power minus lambda y when x belongs to 0 to 1 and y belongs to 0 to infinity, or y is positive. And it is 0 elsewhere. Okay. So now, moving on. We need probability such that x is less than equal to y. Okay. So the first way to solve it is we put the integrals. So our x is going from 0 to 1. So let us put a dx here. And then y is going from x till infinity. Here we'll put fxy. And then we'll integrate with respect to dx and dy. So now let's solve for this. What will this become? 0 to 1 limit. We have already discussed that it is this value. Okay. So performing this integration first with respect to y, we will get lower limit is x, upper limit is infinity. One lambda will drop below, and that lambda and this lambda will get cancelled. And due to this minus sign, this x part will be the first one. So it will become minus lambda x. And now when you put y equals to infinity, and as lambda is positive, this will go to 0. So it will go to this integral dx, which will now become similarly 0 will put first because minus sign is there. So it is 1 minus e to the power minus lambda upon lambda. So this is your first answer, or the first way to integrate it. The second way which you could integrate is, now I'll vary with respect to y first. So the limits will be 0 to infinity. And x goes from 0 to y because of this. This was with respect to y. So dy will be outside. Dx would be inside. and f of x, fxy would be here over y. Okay. So now because this is a function of y, we do not need to integrate this. We can just take it out, all of it, and put it here. And integral 1 dx is x. And now you put the values. So it will become, I'm taking lambda constant out, 0 to infinity. It will become y into e to the power, I forgot a minus sign here, lambda y dy. Okay. I've solved this previously in my previous video. We have known the general form of this integral. So we'll rather perform integration by parts for your simplicity. First, we need to integrate this. So one lambda will fall down and it will become y into e to the power minus lambda y by lambda, rather minus lambda. This minus sign I'll use here and get it plus. And this lambda lambda cancels and we'll differentiate this y and it goes to this value. So next thing we need to integrate is this. Now we have to put limits here, 0 to infinity. When y equals to 0, this goes to 0. At infinity, this goes to 0. So this whole term vanishes to 0. Okay. So we are left with this simple integral, which is the same as 1 by lambda. So now, from the first approach, we got the answer, this. From the second approach, we got the answer, this. Which one do you guys think is correct? Well, for starters, we can assign any value to lambda. Say lambda equals to 50. This seems fairly less than 1, and even this seems less than 1. But what if lambda is equals to 0.01? This we need to compute, but this definitely is greater than 1. But as we know that probability always lies between 0 and 1, so therefore this cannot be the answer. So where did we go wrong? To analyze this, we just need to draw the figure. Whenever solving random variable questions, you must draw the figure. It is a very must thing you must do. So this is x equals to 1. This is x equals to 1 line. This is y equal to x line, right? So your probability region is this when you want to find x less than equal to y. So any value when you integrated above, in the first case, we took x as this and was going from 0 to y, right? Let's check once. So in the first case, no, it was 0 to 1 and it was x till infinity. X till infinity. This was for y, this one was for x. So this makes for the values in this range only because it goes from x till infinity. Whenever x is 0, then let me change the color of my ink. So x equals to 0 correspond to this value. When x is 0, y goes from 0 to infinity. When x is say 0.5, y goes from this 0 to infinity. And therefore we are lying in this region. So this integral is correct. Now let's compare it with the other integral. That is why I will always ask you to draw the diagrams. Sketch a rough graph and it will give you a good idea. It will consume a little bit of time, but at least you will get to the right answer. Now let's observe the other integral. The second integral, it went, for x it went from 0 to y, and y it went from 0 to infinity. For y, it meant this. For x, it meant this. This is for y. So what is this saying? That y will go from 0 to infinity. Let me change the color. Now, this is saying x equals to y. But because y is unbounded, so suppose y equals to 0 will give me this thing, and y goes from 0 to infinity. X is here itself. Okay. Next, y equals to 0.5 will give me this. So x is going from 0 to 0.5. Rather, not this way. X is going from 0 to 0.5 and y is going this way. But what if y we take greater than 1, say 2? So even for 2, this integral, whatever we are trying to evaluate here, will go outside this range. It will also cover up this range, which is actually wrong, because our probability space only should consist of these values. This bounded part, this, which is because of this we need to calculate, and this bound is because x is less than equal to 1 only. Outside this, it becomes 0. And so therefore, what I would like you to do is draw a diagram whenever solving these kind of questions. And hence, you'll never get confused. How to solve this when you draw a diagram? You draw a straight line. This becomes x. This becomes y. So y equals to x, let's suppose. And this is equals to 1. Therefore, this is also equal to 1. It doesn't matter. So how are we going to integrate? First, at x, go to a dx. Now this is the strip. This value is x equals to y. Okay. So first, as your first strip is going from, as your first strip is for x, and your x limit is going from 0 to 1, you write this. And as soon as you write this, write a dx here. Right? Now, for this strip, go to a height y and cut dy. So this you will get. And therefore, y will go from lower limit x till infinity. From the probability space, you can see. And what is the value of this box? This box corresponds to x comma y, because at y you are here. So this is basically this thing, right? So you just need to integrate fxy in this, and you'll get the right answer. And so therefore, the correct answer to this problem is this, and not this. I hope you like the video. Please like, share, and subscribe. Thank you.